My name's Ian Jempson, and I know a bunch of you know me already, but for those who don't, basically I sort of grew up on a farm in Canada, but I now live in central London in England. I run a company called Transforming Digital, and I started that 5 years ago to focus on using AI to extract information from unstructured data. So I went back to school a few years ago to do my MBA, and my dissertation topic was on the strategic implications of AI. So it's kind of cool that after I did that, I then ended up going and doing a lot of programming in AI, and now back in the FileMaker world, so applying this stuff to FileMaker. And so I've given this talk, or variations of this talk, a few times before to different audiences, sort of different levels of I guess technicalness, if that's a word. So can I just get a show of hands? How many people here have implemented semantic search in FileMaker in client solutions? Okay, not very many. How many of you have played around with it and tried to make it work? Okay. And is there anyone here who has never touched it before? No experience. Okay, great. So what I'm probably going to do is try to pitch this at a point where the people who've never seen it before, by the end of this, should have sufficient understanding to actually try implementing it in a solution and play around with it. And that's the best way to learn, play around with it. Plus, I've got to say the Claris training materials on the topic are really, really good. But they're probably best used if you've played around with it a little bit beforehand. For those of you who've got more experience, there's a few other things in here that I will touch on that will still hopefully make it worth your while. Some of the things you need to bear in mind when looking at combined solutions. So yeah, so the goal is really, by the end of it, we're going to understand FileMaker's implementation of semantic search to a consistent level. Demos I did here, actually it's not quite 100% local, but most of the demos I did here were running using local large language models. So we're not connecting to the internet and using large language models online. And basically the large language model is running on my Mac. And so the first question is really, why semantic search and why does this stuff matter? And what it can do is it can make our searches context sensitive. By this, what I mean is that we can enter a plain text query into a system. It should understand the context that we're asking it about, and then give us an answer that makes sense. And if I use an example, let's take Netflix. If I search on Netflix for films with a strong female lead, what I get is I expect to see things like this: Kill Bill, Alien, The Devil Wears Prada. Actually, I had a much better slide, but somebody pointed out yesterday that I'd not got licenses for the posters that I was using. So don't get close. That was the last bit. It changed last night. But this is what Netflix is. Sorry. Netflix gives me a message about keywords and not being able to find anything. And it's kind of weird because, to be honest, I would have thought that Netflix, this to me would just seem like such an obvious example of where semantic search would be useful. So I don't understand why they've not done that, but well, that's. So if we now compare it to the search that we already know, semantic search allows us to look for the meaning in text or images or audio, as opposed to keyword search, which everybody here in FileMaker is used to, where we're searching for literal text. If we enter a word, FileMaker is going to find that exact word, subject to the additional conditionals that we've got, wildcard search and so forth. So semantic search basically works on the basis of similarity. It's imprecise, and you could view it as saying, find me something like this. Whereas keyword search is very precise, it's exact. It's saying, find me exactly this. If you bear that in mind, the semantic search is fuzzy and imprecise, whereas keyword search, as we all know, is very precise. but they're much more effective used together. So if we combine keyword search to filter down the list of records first before we perform our semantic search, we can get much more effective results from that, or the other way around. So I'm going to do a quick demo. Apologies for the first demo, it's not very good. This is from a product that I'm building that extracts information from meeting transcripts and video transcripts. And this particular part is something that I used when I was writing my dissertation, when I was doing the research. There. Where I was interviewing a lot of people and I was looking for different themes out of that. And so, for example, in this case, we were looking at the theme of build or buy. So the semantic search here was basically on the search term, the build or buy question, and it's found these snippets of a video transcript that discuss that topic. And the next demo is basically searching for images in FileMaker. So I've got 25,000 images here. They're all downloaded. If I search for St. Paul's Cathedral text, it brings up that image. That's actually in my neighborhood. It's about a 10-minute walk from my house. We can search for New York, Tokyo at night. So Northern Lights. So this again is running in FileMaker on my local server. So 25,000 records, actually, that's pretty good performance. So if you look at why do we want to do this? We can prove existing processes, save money, it can add new capabilities or enable new processes. And we can do this by doing natural language search on unstructured data. We can categorize text or images or group things by similarity. So I was having a chat with someone before, and they've got a database of service records going back several years, tens of thousands of these things. And what they could do is that if they've got a new service record in the system, they could potentially perform a semantic search to find similar service records. And once they found the similar service records, what they could then do is say, here's how we resolve these problems, or these are the most common causes. And so this is sort of a case where what they're talking about was this is large pieces of equipment that would cost a lot of money to ship. So they could save substantial amounts on shipping, parts that weren't needed had to be shipped back, as well as enabling quicker resolution of issues. So that's just sort of one quick example. So what's embedding thing? Basically, you keep hearing about embeddings. And the embedding is a vector representation of an input, where what we do is we have an input, which could be text, so in this case object. We pass it into an embedding model, and it returns basically a vector of numbers. And this vector of numbers represents, according to the model, semantic meaning of the input text. Now the outputs will vary depending on which model you're using. Models can be general purpose, and most of the models that people are using, for example, the OpenAI models, are general purpose models. Whereas you can also fine-tune embedding models. If you've got a specific domain knowledge, it's possible to fine-tune models for that. So the output would look like, in this case, so we've got a chunk of text that was the input, and then its output, 1,536 dimensions. So basically just a big stream of numbers that represents the semantic meaning of that text. And this, sorry, my keyboard is not, can also work for images and text. And in this case, we've got an image of a dog, and we've used a multimodal model that basically will give us the same kind of output, a large string of a vector of numbers. So in that case, we would be able to search for the word dog in the snow, and it would find this image. Skip over this one. And when we do the search, we get a result back. FileMaker sorts by similarity. It says these vectors are the most similar to one another. And it uses a method called cosine similarity to do that. And it scores range from -1 to 1. So if we get a 1 on the cosine similarity, that indicates that the two vectors are identical. So that it's going to be the same piece of text or the same image. 0 means that they're unrelated, and -1 would mean that they're actually opposite in terms of semantic meaning. And we store these in vector databases. So FileMaker now provides vector support within the database. PostgreSQL with the vector extensions does as well. MongoDB, ChromaDB, Milvus and Pinecone are basically in the cloud. They're vector databases in the cloud. So these are all things that can be used to store these images. Sorry, these embeddings. And the process is basically a three-step process. We've got sort of the planning stage, we've got data preparation, and then we've got a data query stage. And what I'm going to do is I'm going to go through these. Once I've gone through that, then we'll show a demo of building this, starting off with just a plain CSV file, converting and adding semantic search to it. Following that, then I'll go into more detail on the commands we have. So the planning stage, we look at what data do we want to embed, what data do I want to query, which is actually a fairly important question because a lot of people, when they look at this, think that it's somehow magical and they can just query that it will find across all fields in their database. That's not the case. You need to explicitly decide what data you want to generate embeddings for and then query. Decide which model. And what I normally recommend is when people are getting started off, just use one of the models from OpenAI. That's the simplest. Local or from a web service. So you can run embedding servers locally, or you can use a web service such as OpenAI. And then you've got technical considerations we'll get to a bit later, like things like how does this affect our choice of server? How do we store the embeddings? That kind of thing. So the data preparation stage looks a bit like this. From our FileMaker database, we would feed our image or text into an embedding model. It's going to return the embeddings, and then we store the embedding within FileMaker. Now with FileMaker, that process is basically one script step. Well, there's actually a couple of script steps, but we can accomplish it really, really easily with a single script step in our script. The data query side of it is quite similar. In FileMaker, we take a query from the user, we pass it to the embedding models that returns embeddings for our query, and then FileMaker searches for those embeddings and returns a set of records that it returns the top, let's say, top 10 records that match most closely to that, sorted in order of similarity. And we can then extend that a bit further to implement into the retrieval augmented generation, where what we do is we do the same thing. We search the embeddings, we get the results back, we take those results and we then feed that to a large language model, which can summarize or that, and then send that back to FileMaker, and we can then see that in FileMaker. That's where my keyboard is not. Okay, so in terms of the demo here, what I'm doing is I'm just taking a CSV file. I'm going to convert the CSV file, make it into a FileMaker database. I speeded this bit up because you all know how to do this. We're just going to do what we need to do to prep this for. We're then going to add in a query field, a global text field where we can enter our search into it. Let's make that a global. Essentially, from start to finish, you could have this done, converting a basic CSV file for a really basic thing in like 10 minutes. So that's kind of why I encourage people to play around with it. You can, I probably should have cut this all out of the demo, but.
Choose a container field type.
Sorry?
Could you explain why you chose a container field type?
Oh, for the, yeah, I will get to that. Yeah, so the embeddings, when we add the fields for the embeddings, we use a container fields type as opposed to text, even though that's a little bit counterintuitive, but I will explain why. We then get our OpenAI token. So if you're unfamiliar with this, you'll need an OpenAI account. Once you set up your account, then you can, from that, get a token that will give you permission to query their embedding models. You can go ahead and use this token if you wish. It's been deleted. Not that I don't trust you, but so yeah. So we basically run about. We get our key token, and in FileMaker, I've added that in as a I think I added it in as a custom function. In this case, just because as a custom function, it gets sort of autocomplete when typing it in, and it gives me one place that I can have that. Okay. So you then add a generate embeddings script. Generate embeddings. This is where just write a script in FileMaker where that's going to populate the embeddings for the records we've got in the database from our CSV file. So what we need to do here is we need to, I'm just going to set a couple of variables for our model name, things like that. And we also then going to need to configure our AI account. So I should have sped this up.
If you add new records, do you have to run the script again?
Yes, you would. Yeah. So the embedding will happen on the generated on the set of records you got at the time when you do that. So if you're adding new records, you'd need to maybe schedule a process to add the new embeddings. Likewise, if you decided to change embedding models, you would need to redo it also.
You could search for anything modified since a certain timestamp and update modify.
That's correct. Yes. The question there was that you could find records that have been modified since some timestamp, update the embeddings for those records. Yeah.
If you do it with a script trigger when you save the record, is it fast enough to do that, or does it take a few seconds for each record?
Well, it depends on your connection, but the question there was that could you do that in a script trigger? Yes, you probably could. But it'd be so
Script on script.
Yeah, you could do a perform script on server. This can happen on server as well.
Embedding is per field or per record?
The embedding is per field, or I will actually get to that. How we do that. So the next section of this actually is going to much more detail on what the steps are here. So most of the questions you've got will be answered in the next section of the. Okay, so you can see it's actually been pretty simple to get this up. But we've basically got two scripts necessary to prepare the file perform search. We've configured the AI account that sets our provider, OpenAI in this case. And then we've got our insert embedding and found set. Or we reference that account. We'd say which embedding model. And then we specify which field we want to embed, the target field, where are we storing that embedding, and we're replacing the target content. So if there's already a value in that field, it will replace it. So that's kind of at the most basic level all you need to do to kind of set things up to do the query. So the next step, we need to actually run that generate embedding script. And then we add a search script. And it's actually very similar. We need to configure the AI account, and then we can perform our search.
The configure, Ian, that is per session, not per script. Am I right on that?
You're correct, yeah.
Yeah.
So the question was about the configure AI account. The configure AI account is per session, and it's also specific to the provider and the model. So if you've got different things going on with different models or different services, you may need to configure different Yeah, so after you've so essentially you can see here what we've got is we perform semantic find script step. We specify which account, which embedding model we want to use. This generating the embedding and the search need to use the same model. If they're different models, it just will not work. And we specify a target field, which is what are we searching on? And we can specify all records or found set. So that's it, basically. We then wire that up to enter a value into a search query. We can then run our script. And so I've asked for, I want to see a really great hotel, and it's shown me the hotels where you can see the rating of the hotels is 5. If I then ask it for the really bad hotels, it's going to show me a set of records where the rating is 1. So that kind of, at its most basic, is an implementation of semantic search. You can get much more elaborate than that. But
sorry, is it possible to see the similarity score?
Yes, I will get to that. The searching. Actually, to be honest, we've just seen that. So I'll just skip over that. So we look at the AI script steps. Okay, so I'm now going to the script steps in some more detail. So we've got the configure AI account script step. You can see we've got 2 variations of it. The first one, line 5, is using the model provider OpenAI, and the second one on line 6 is using a custom provider. And the difference there is that sorry, off track here. Yeah, okay. So the account name and the configure AI account script step, it's scoped to the FileMaker file. It's cleared when the file is closed. So if you configure it once, that basically will persist for the session every time in FileMaker. If you close the FileMaker file, that's then cleared. The model provider that we specify could be OpenAI, it could be Cohere. Claris is adding more providers, so Anthropic is going to be coming soon. And you can use custom providers. And if you're using a custom provider, you need to specify the endpoint for the API. So a custom provider, Claris provide on server, they provide us with an embedding server that we can run. The configuration that they've done at the moment is quite tricky. Claris has got a tech blog about it, and I think Wim wrote a really good article describing how to install it. However, as you just saw a few minutes ago, they're making it much, much easier. So it's going to basically be a really simple thing to configure in the future. So I provide... Sorry, my computer is showing a different slide. And that's so. Anyway, if we use a custom endpoint, we use that for a local large language model. So FileMaker Server includes an embedding server. You can also use products like LM Studio or Olama. They're both free, really easy to use. They can be downloaded. You allow you to run large language models and embedding models on your own hardware, your own computer, and they're really good. And to be honest, that's what I've been recommending. I've been recommending people use Olama because it's super simple to download, install, and use, and it works really well. You can write your own embedding server, which actually is less difficult than you might imagine. I've built this set of tools that I've been using. So I've been doing semantic search stuff for a couple of years now before FileMaker had it. So that's kind of another approach. So when we are using our config, there. Okay. If we specify custom model when we're configuring it, we need to specify what the endpoint is. So that would, in this case, I've used a custom function to that, but that would be the URL pointing to the embedding server that you're using. So that'd be either the IP address or domain address. If you're using the FileMaker model, the default port is 8080, and actually it's going to, for most of these things, it's going to be 8080. I think with Olama, it's 1234. You need to specify that when you're specifying the custom endpoint. So my suggestion is actually when people are just trying this out for the first time, just use OpenAI because it's a lot simpler to get started with. And you don't have to worry about how do you run an embedding server, networking issues, and all that kind of stuff. So if we go back to the script steps, we've got the insert embedding script step. This acts on a single record. And we specify the account name, which we configured in the configure script step. We specify which embedding model we want to use. We specify the input, what field do we want to use for the embedding, and the target. So the target is basically what field do we want to store the embedding in. We've got insert embedding in found set, which basically will do a very similar thing, but it'll do for the full found set. So insert embedding will run one record. Insert embedding in found set will do what it says, and it'll run it for the found set of records. So we specified source field, target field, whether we want to replace the target contents, and we've got some parameters as well that I will get into a bit later. Insert embedding is not the same thing as insert embedding for found set. And if you look at a comparison, you can see that the account name is the same, the embedding model part is the same. You'll notice that on insert embedding, it says input, whereas insert embedding in found set says source field. And likewise, the first one says target, and the second insert embedding found set says target field. And the insert embedding in found set has these additional parameters. So it's a subtle difference, but it's an important one. So this chart kind of shows the differences. Insert embedding for the source allows you to use the calculation engine. So whereas insert in found set specifies a field. So insert in found set, you can only embed the contents of a single field. As with insert embedding that acts on the single record, you can take advantage of the calculation engine and you could combine fields and build a calculated value that you want to search. Likewise, the target in insert embedding, you can use a field or a variable, whereas in certain found set, you can only specify a field. Replace target options doesn't exist in insert embedding, and the parameters don't exist in sort of embedding, but do it in search and found set. So this parameters allow us to specify different options for the operation. And it's really important that you need to choose what data you're going to generate embeddings for. That it can't just do all the fields in a record automatically. So insert is more flexible, but is slower. And one of the things it does is it enables chunking. Because we can use the calculation engine, chunking is where we break the input down into smaller pieces. So if we've got, let's say we've got a text field that's got 100,000 characters in it, that's not going to give us very good results for embedding, because the embedding model generally not going to be able to handle giving us a single vector embedding that represents 100,000 characters. So what we need to do is to break that down into smaller pieces, and that process is called chunking. I'll just kind of touch on it really briefly, but just so you're aware of it, that if you've got very large pieces of text, that may be necessary.
Is that because there's a limited amount of numbers in
The question is around because of the limited amount of the context size in the models.
Yeah.
For some models, yes. But the other thing is that there's a number of technical issues with embeddings, which what happens is they tend to favor items for the beginning or the end of text, and stuff in the middle tends to get left out if it's too long. It can get fairly technical why, but that's in terms of chunking. What we can do is we can basically do it in a number of different ways. We can break things up by fixed size, say maybe breaking it up into chunks of 100 characters. We can do it by sentence or paragraph. We can look at document structure. So if we've got a markdown document that is structured with the text showing headers and subheaders, you can break things up that way, and that gives you a pretty reasonable, good method to do it. You can also do semantic chunking, which is a bit more difficult and requires a lot of talking to a large language model and a lot of calculation. It'll be quite time consuming and expensive because you're generating a lot of calls back and forth to models. It's also going to be really slow. I'm just sort of mentioning it so you're aware of it. So when it comes to storing the embeddings, this is a can of worms. And you can store them in either text or container fields, and there's a right answer and a wrong answer. The right answer is you want to store them in a container field. And basically it's smaller, it's much faster. The Claris engineers have highly optimized this stuff to run on containers. And initially they didn't want to provide the ability to do it on text, but there are some reasons why. Also, doing it in containers is not going to ruin your database. Ruin how? So yeah, you don't want to do embeddings in a text field. And if you really, really insist, you have to turn off automatically create indexes. Because if you've got a string of numbers that's 1,536 numbers long, and FileMaker tries to generate an index on that over your set of records, you're going to have a huge bloated index that actually is no use for anything. And when that happens, it's going to basically your database server is going to stop until it's done. It's just a bad, bad thing.
Additional storage to see what embeddings.
Well, probably not. Okay, so this is for 65. What I used was I embedded a 65 character chunk of text. And this is for the individual embeddings. In a text field, if I used a large OpenAI model, the actual the embedding itself is just under 39,000 characters. That's, if you think about it, That was like the embedding for 65 characters of text. And for 100,000 records, that gave me a 3.8 gigabyte database. That's just for one sort of embedding, one field. If I use a small model, it's half the size. If I used a different model, but sort of in between in terms of context length, it's about 2.6 gigabytes. And if I store that in container fields, you can see that we went, in the case of the large model, from 3.8 to 2.4, the small model from 1.9 to 1.2. So containers are definitely a lot smaller. Yes.
One thing that you might mention is that the length of characters doesn't matter as much as the embedding model, because a large paragraph will produce the same size.
Exactly, yeah. So Michael's comment was that the length of characters as the input doesn't matter. It's the length. The model determines the length of the text or the container that is generated by when doing that. So this is an example of 4 different models. I used the Claris semantic search training just as an example. And you can see the different models gave different sizes of database. And that was, I can't remember how many, I think that was 100 records. So you can get some quite substantial differences in size for based on the model that you're using and the number of dimensions. So it's the number of dimensions that causes the size differences. So yeah, size is a function of the number of dimensions, the number of records, not the length of the text being embedded. So this has a bunch of implications for FileMaker and FileMaker Server. So ideally what you want to do is have a separate file for vector containers. The reason is that that gives you the ability to tailor your backup strategy to deal with this. Because if you put this all in the same FileMaker file, you're going to end up with potentially enormous backups because of the vectors. So yeah, this gives more flexibility. In terms of cost, it's actually not that expensive. So most models price per million tokens. So using the text embedding small, it's 2 cents per million tokens. So if you're going to embed 42 million tokens, so I did a set of 900,000 records, and it cost about 84 cents to using the small model, and it cost $5.46 using the large model, and then their other older deprecated model, $4.20. That actually points out something interesting to me, because the last model has been deprecated by OpenAI, but they still allow you to use it, but it's actually more expensive than newer, better models. So as they come up with newer models, you may, if it's costing a lot, you may want to think about, upgrading to a newer model, and that would require re-embedding everything. Now, these numbers don't sound like a lot, but if you've got firing a lot of queries at it, it can mount up. So the next thing is we look at is I'm going to try to speed up because I've been a bit too slow. Embedding performance. So I tested this by generating 1,000 embeddings at a time. I called this wire perform script on server to minimize the effect of my network. And I used a model on my local API that I wrote. And what I did was I varied this parameter called max rec per call, and that determines how many records it processes at a time. So playing around with that enabled me. So if you look at this, you can see that if we've got that set to a fairly small number, that it took longer to do that 1,000 records, sort of about 90 seconds. The default setting for FileMaker took about 45, 50 seconds, and increasing that value up higher reduced it quite a bit. But by the time it had been set, say, about 100, it didn't really make too much of a difference. The maximum value is 500 for max records can call. If you set it to more than that, it just defaults back to 20, which I think is the default value. Bit nerdy, but if you're writing your own API, you can actually optimize further by doing this as a multiple of the internal torch size, but you don't need to know that. So the default setting for the for this, I think, is a bit too small. The default value is 20. If you adjust it to over 100, then you're going to get much better performance. And yeah, that's just a few of the things I found about performance. So the most important script step was, the perform semantic find. And we've got two variants on perform semantic find. We've got query by vector data, and we've got query by natural language. Query by vector data will allow you to compare two values. So if you've got an embedding in the system, you can use that as your criteria for the find, and it'll find similar records. So that's useful, say, for example, if you wanted to find images that were similar to this one, or something I'm working on for a client that's in proof of concept right now, is they're a music publishing company, and they want to find songs or snippets of songs that sound similar to this one. So I found a model that embeds audio, and they can do that. So that is definitely something I couldn't show as well because of copyright. The other one is natural language. This is where we enter text or query, like we saw in our earlier demo. Where we enter the text, basically what it does is it goes off, talks to the embedding server, embeds that text, and then does the query. So vectors, when you want to find similar items, and text when asking a question. And when you can also specify that you want to save the result into a JSON object. And someone asked about, can you find similarity? And this gives you the value for the record IDs. This gives you the similarity, the vector similarity. And as we talked about earlier before, the value ranging between -1 and 1. So this is normally returned, because it's a JSON object, it's going to be unsorted, but FileMaker, when you perform the vector search, is going to give you sorted in order with the highest similarity first, the found set. So it's a bit interesting because it gives you a found set that's sorted, but you're not able to resort by that unless you take advantage of what you get back in the result. So basically, FileMaker's changing it, so it'll search on server whenever possible. If you can search directly on the embedding table itself, it's going to be much, much better. If you search through a relationship, it's going to basically drag everything down across your network. And because these files are big, that's going to just bog down performance. So you can search on the embedding table and then do a go to related records. But that then gets you the thing that you're now no longer sorted. So that's where the that JSON object can help. Search has to be on the same model. Just it won't work otherwise. In terms of query performance, this is running on my Mac Mini small server, and basically what you'll find is that the performance. This was on a 900,000 record database, and this is searching on the found set. So I was varying the size of the found set performance. And the good news is it's quite linear based on the number of records in your found set. And what I was getting was sort of quite good performance. So, it was sub 1 second for up to about 30,000 records, but this varies depending on the model, your server, a number of things. And then just like I said, completely linear. But then what I found was once I got to 700,000 records, it then took a huge dip in performance. And the reason for that, from speaking to the developers at Claris, was probably that my server at that point was running out of RAM, and my server is starting having to swap memory to deal with the large volume of data that was being processed. So what we want to do is pre-filter it by index search if possible to reduce the size of what you need to search on. Smaller number of dimensions is faster. It's a similar chart for a smaller number of dimensions. So conclusion, basically, search is faster with smaller number of dimensions, but the search quality potentially might not be as good. And yeah, where possible, pre-filter the search. And that was running on my local Mac. I also basically talked nicely to Hugging Face and managed to persuade them to let me rent an A100 from them. And what I found was that it was several times as fast as my M series Mac. But the thing is, A100s are really, really expensive. Large GPUs are tremendously expensive. The other thing that I found was that network latency came into it. So while the actual search, when I looked in my API at the times for the search, they were 5 times as fast. However, the network latency basically meant that a lot of that advantage was lost. So Mac servers got good GPUs. The M1, M2, M3, and particularly the M4 Mac Studio gets to be phenomenal. They've got really good GPUs, and this will take advantage of that, and they'll be really fast. Yeah, and where possible, but I cannot remember what hardware it takes advantage of on the Windows side. I'd need to look that up again. So we've got a number of new functions as well. We've got things like get token count, which allows you to look at how many tokens this is going to be using. Tokens are not exactly the same thing as words. They're similar, but you can see that, for example, New York is this 2 tokens. The word wouldn't is 3 tokens. And this allows us to look at what we may be spending beforehand in search. We've got a cosine and similarity function that basically you can pass it to the vector values and it will return the cosine similarity. You have to use the same model. Both vectors have to have been generated by the same model, which is a consistent theme throughout. So that implies they've got the same number of dimensions. The data types of the fields should be the same. So comparing text and container sometimes seems to return different results or return a question mark. Not quite sure why, but it does. And it should be a normalized vector. If you're using a model from OpenAI, it will be a normalized vector. So I'm not going to go into that. So the get embedding as text and get embedding as file functions allow you to convert between the 2 formats. And where you may want to use that is if you're interacting with an external API, an external system that has vectors. Okay, so which embedding model? Basically, it has to be one with normalized embeddings. Getting started, just go with OpenAI. It's going to be simplest. So, yeah, so where it works well with images, comparing images. It can work well with audio, as I've seen. It works well with bodies of text. Where it performs poorly is when we've got single words or numbers or just dates, because it doesn't have enough information to get a context. So I spoke to someone a while ago, and they were talking about getting poor results, and their system, they were searching for things on security. But if you use the word security, it could be talking about security or securities. There's any number of of potential meanings for this, and they can confuse the system. So my final thoughts. Right. So you've got to be consistent with this. Different embedding models will produce different results. You can't search across different embeddings or embedding lengths. And using normalized embedding models will provide better performance. And to be honest, the cosine similarity function in FileMaker seems to fail if you're using unnormalized vectors. There may be some help coming for that in the future. So yeah, if anyone wants to talk about this further or needs any help implementing some of this stuff, I've been working with it for a couple of years. So thanks very much for your time. And 9 minutes. Do you have any questions?
No.
Yes.
When you talk about changing your last overlap chunks.
Yeah, so the question was, if you're doing chunking and breaking it up into lengths, so you do overlap, so the chunks, yes, you will get better. Here across. The other thing is, so in FileMaker tools, you can
When you do that, you're already doing right
now.
retrieval.
So I just, you talked about mock, suggesting we'll do OpenAI. So within OpenAI, there's very specific embedding. Those are sharp. What's the risk of OpenAI changes? Let's say the embedding models for you, or whatever it's called. If that changes or something changes within that model, can that break?
So the question was, if OpenAI changes break things. And the answer is yes. If they break things. However, OpenAI, they've got at this point they've got billions of users. They're going to follow the other thing,
But also like help
Sorry, can we consider the question answer period as part of the session, please? If you need to talk, go out. I can't hear the question. It's not fair. People are trying to listen. Thanks.
Okay, yes. You said that when you're trying to combine multiple fields, when you're doing your initial embedding, that you would use the calculation, like instead of just picking one field, you would use your calculation to concatenate fields. Yeah. Can you just give us a little bit more detail? So let's say you had something like an inventory record that would have a part and a description and alternate part numbers, things that you might want to include in the embedding. Yeah. Exactly how do you do that calculation? Is it just ands, or it's to be honest, yeah. You can so just field and field and field. You can do so yes. So make sure they include labels. Yes. Michael just pointed out, if you're doing that, make sure you include labels for what the different pieces are. So if you've got a part number, you might say part number, half a part number, then the equivalent parts or replacement part numbers would be labeled and then followed by those as well. So just a simple concatenation, nothing. Yeah, you could do that. Yeah. Okay.
So you concatenate multiple fields together and use a single embedding?
Yes, that's correct. Yes. Yeah. So
you don't actually have to have a one-for-one correspondence between field and embedding.
Right.
You can concatenate multiples together.
That's correct. Yeah. Now you do need to be consistent on that. Yeah. So one approach there would be to basically have a calculated. You could do an unstored calculated field to have a concatenation for that. Sorry. Yes.
You talked about normalized vectors. What is this? What is normalizing? Or how do I know if it's not?
Okay, that's a little bit of a can of worms, and
Okay. Fair enough.
Is the one you're the one did?
yeah, what it basically does is it resizes the all the numbers in the vector so they're consistent and all scaled the same. That's the idiot's way that I would, that's my understanding.
Yeah, that's it.
So, yes,
This is a very general question. If you have something that's got an application, say medicine, diagnostics, or something like that,
Yeah.
and you want to search a model, but don't even worry about anything in the model that's got nothing to do with the medical profession. Is there a way to use the AI model and just say, forget it if it's not medical? So it doesn't take other meanings of blood vessel or something and think, or do you have to sort of create a limited model?
no,
especially for that
no,
purpose?
with a general purpose model, not really. It's just going, you're searching, it's going to generate as it goes. It is possible to fine tune embedding models, but that's, to be honest, that's
so
way
if you
beyond-
wanted
that's
a model,
kind of way beyond the scope of talking about here.
okay, I'll catch you later.
It'd be a difficult task.
Are there specific like medical embedding models or
There probably are. So, a lot of niche areas have got specific models. So, in the case of finance, for example, Bloomberg has got built up a number of models because they're specialized in finance. They're expensive.
is there like a legal model you're aware of that's better at ciphering
There's actually there's a site called Hugging Face, and on there you may find it's basically a collection of models. So you'll find a lot of models there. With using models from Hugging Face, that's where you need to check and make sure that they are normalized because not all of them are. So that's kind of where you need to worry about that. Okay. Yes.
One more question. So thinking about security, so the security aspect of this you need to be aware of is when you're sending your data up to generate the embeddings,
That's
right? So that would be-
that's actually a really good point. FileMaker embedding search compared to other solutions incorporates the FileMaker security model when you're searching. So the results you get back basically are subject to the existing FileMaker security framework. Whereas if you use an external system, an external vector database, you need to basically re-implement security in that, and that's a non-trivial thing. So that's, well, FileMaker may not be as fast, it has that advantage of the built-in security that we're all used to and expect.